All right, so when we're graphing lines, now we talked about this a little bit yesterday, right? We said we only need 2 points to define a line. So we just need to find the coordinates of 2 points and then connect and extend. Well, you can always just use a t-table for that, right? With a t-table, I can just pick values of x or y for that matter to plug in and then solve for the other variable, right? So for example, I could pick something like arbitrarily, if I wanted to, I could pick x equals 6 and plug that in for x and then calculate the corresponding value of y, right? Can anybody think of the easiest values that I could choose? Yeah, how about 0? What if we chose, for example, x equals 0? Whoops. What if we chose x equals 0? Well, then solving for y is pretty simple because the x term just goes away. Everybody see that? Okay, so choosing zeros is a great way to find, those 2 points that I need. Now, sometimes it doesn't make sense because we end up with fractional answers and maybe we'll just do something else. But in this case, picking x equals 0, look, I can just, it's called the cover-up method. I can just cover up that term and then solve the other equation in my head. So what's y? -6. There you go. So I get the ordered pairs 0, -6, so like right there. And then what's another really easy one I could do? Say it again? Yeah, let y equal 0. Yeah, why not? If I let y equal 0, in this case, man, I keep doing that. Well then look, I could just cover up the y term. And what do I get for x? 15, yeah. That one's not on my graph, so that's not super convenient. But if it were, I could just go out and plot that point at 15, 0, and then I got 2 points I could use to connect and extend, and I got my line. Make sense? Okay. So intercepts are frequently a good way to approach that. And if we want to be just a little more rigorous about it, we know what the intercepts are, right? The x-axis intercepts the line intersects the x-axis at the x-intercept. You obviously know this. The line intersects the y-axis at the y-intercept. And so by plugging in the zeros for x and y, we're going to those places, right? Every place on the y-axis has an x-coordinate of 0, and every place on the x-axis has a y-coordinate of 0. Right? So for example, by plugging in 0 for x, we find the x-intercept. So plugging in 0 for y, sorry. Plugging in 0 for y, we find the x-intercept. By plugging in 0 for x, we find the y-intercept. And then we can just connect and extend and we got it. Okay? So the x-intercept, that's one that we look for a lot. Sometimes we call that a root in certain instances. We'll talk more about that later. A lot of times we'll call it a 0. How come it's a 0? Because that's the place where the y value is 0 and f of x equals y, right? So it's a place where the function has 0 value. Its y value is 0. And then sometimes we just call it a solution depending on what the context is. And you'll get a better feel for that as the year goes on, like when we use each term. Again, just summarize here. To find the x-intercept of an equation, what do we do? If I want to find the x-intercept, yeah, that's where y is 0, right? So all I have to do is just set y equal to 0 and solve for x. If I want to find the y-intercept, what do? Set x equal to 0 and solve for x. Exactly. Okay. And just one more practice example. What if I've got this equation, this linear equation, and I want to find the x-intercept? Well, what am I going to do? Yeah, set y to 0 and then solve for x. So what's x? You can do that in your head, just 2 quick steps. Yeah, right. So if y is 0, we just get negative 25 for x. Okay, if I want to find the y-intercept, what am I doing? Cover up x, and it's already solved, right? If x is 0, y is 50, and we got it. Okay. For your notes, I'll shut up and let you work. Okay.